Okay, hello people. Very sorry I cannot be with you for this lesson. But nonetheless, we still need to proceed. Okay, if not, we'll be severely behind time. So anyway, this video lesson, I will try to finish up 18.0 and you will need to do the homework 18.1 and 18.2 on your own. So I will just use the first 10 minutes to recap on what we have learned. So basically for this particular worksheet, we focus on learning how to identify series connection and how to identify parallel connection. And why do we want to do that? That is because in the future we will be given a very complex circuit, and by being able to identify what is series and what is parallel, we will then be able to actually combine resistors. So for example, if I know that E and F are in parallel, I can actually combine them. And like here, C and D are in series, I can also combine them. So from a very complicated circuit, you can actually simplify it until it is just one resistor, one battery. So it will be able to help you solve complex circuit. At the same time, through identifying the series connection, you can also conclude some very useful characteristic in the circuit. So for example, if I know that A and B are in series, I can say that the current that flows through them, IA and IB, must then be equal, right? So this is one of the characteristic of a series connection. And another characteristic is that I know that if now my circuit, if in total from this point to this point, I have a potential difference of 9 volt, and I know that in A I have used 5 volt, then because A and B are in series, I can say that then I would know that B will use up the remaining 4 volt. So we say that in series connection, there are three characteristics. Number one is that the current flowing through the component in series will be the same. The second characteristic is what we call the voltage. In another word, the PD across the component is actually shared. So if you have a EMF of 9, and if I tell you that the PD across A is 5, you can then quickly deduce that the PD across B is the remaining 4 volt. The next and the last characteristic is that we say that when components are in series, if you have a higher resistance, you will get a higher PD. So for example, if you look at this circuit, resistor A use up 5 volt, resistor B use up 4 volt. And if now I need to make a comment on the resistance of A and B, I can safely say that your RA must then be greater than your RB, and that is because your VA is larger than your VB. Okay, so this will be very useful characteristic when you need to calculate current, voltage, or even finding out whether the light bulb will light up brighter, or will it be dimmer when something in the circuit has changed. So to identify series connection, very straightforward, as long as there is a singular path and there is no junction on the path. So for example, here you can see that AB is in series. Now the other thing that you learn is how to identify parallel. So to identify parallel connection, we say that the component has to be trapped within the same two junctions. So for example, here you can see that resistor A is trapped between the blue color junction, and resistor B is also trapped between the red color junction, and this blue and red are the same junction. So we say that A and B are parallel. There's one exception. So for example, if you see that there's no electrical component in between the two junction, you can say that these two junction can be considered as the same. Yeah. So for parallel characteristic, we say that if two components are in parallel, then the potential difference across them will be the same. So here in this dummy circuit, you can see that the battery EMF is parallel to resistor A and at the same time parallel to resistor B. So you can see that the voltage across them is the same. The other characteristic about parallel circuit is that the main current will be split into the different branches, and as such you can see that the current A going through A and the current going through B, when you combine them you will get back the main current. And the characteristic of this sharing is that if your resistor is of a high resistance, you will actually have a very low current. So for example here you can see that resistance A have 4 ampere flowing through, whereas resistance B has 10 ampere flowing through. So you can actually conclude that your resistor B is actually less than your resistance A because your current flowing through B is larger than the current flowing through A. So that's what you can conclude looking at the parallel connection. So I think the last lesson we stop here. Basically in this part I'm trying to provide you with a numerical proof that what I have said on top is true. So here you will notice that after we do the derivation, the first thing you notice is that R1 is of a higher resistance than R2, and so by the third bullet point, when you have a high resistance you would expect a low current. So let's look at this. You have a high resistance and you indeed get a low current, right? And here you see that if you have a low resistance you will get a high current. So bullet point 3 is correct. Number 2, whether the two current can combine to form the main current. So here if you look at the ammeter, so over here if you look at the ammeter, it is trying to tell you that the current that is coming out here is 7 ampere, and by applying the Ohm's law to your R1 and R2, we have worked out that on this branch the current is 2 ampere, and at this branch the current is 5 ampere, and you can see that 5 plus 2 indeed give you the main current 7 ampere. So the second bullet point is also correct. So down here the blanks, so basically we just need to fill out what we have observed. Number 1 is that they will have the same PD because they are in parallel. Okay, and I gave you I gave you an explanation because of this. So if you have forgotten, I will just quickly provide you with one. So we say that, let's say there's a charge coming out from the battery. Between the battery and this point there is no component, so it will still have 9 volt. Okay, so extending from this logic, then this point will have also 9 volt because there's nothing in between them. Extending from the logic, then down here it should also be 9 volt, right, because there's nothing between them. Same thing, extending from that logic, down here it will still be 9 volt. Now when the charge return to the battery, it must return to the battery at 0 volt. So since there's nothing over here, down here will be 0 volt. Extending from the same logic, I would have 0 volt here and 0 volt here. So you will see that actually the potential difference between parallel connection will give you the same PD. So that's how this is being explained. So the next bullet point is what we have observed, right? When you see that there's a high resistance like here, you will get a low current. So that is what we have observed and calculated. So Ohm's law supports that. And the last bullet point is that these two subcurrent, when you combine them, you get back the main current. So it is equals to the main current. So that is what we have learned in the previous chapter, how to identify series connection, what is the characteristic, how to identify parallel connection, how is the characteristic like. So there are 3 characteristics for series or parallel connection. So down here, question 3 is basically an exercise to test whether you can truly understand how to identify series and connection. So I will show you how to go about doing this. So for example, now the question asking you what type of connection is between C and D. So C is here, D is here. There is a singular path with no junction on the singular path, so it is in series. And what we can deduce from there, the current through C and D are the same. So how about A and B? A and B, definitely they are not in series because you can see that there's a junction here. So we say that this is not series. The next thing we want to check is if they are parallel. So how to check they are parallel? So A is trapped between this dot and this dot. B is trapped between this junction and this junction. So they are trapped between the same junction, and we say that, oh, okay, they are indeed in parallel. And what's the remark that I can say about this? Well, I can say that the PD across C and the PD across D are the same. So what I want you to do in the next 5 minutes, so in this video what I will do is that I will start a timer and I will set the timer to 5 minutes. Your job, very quick, very easy. I want you to do it this way. I want you to first answer this. Are they in series? So for example, C and D, I will look at C and D and I will ask myself, is it in series? Okay, it is in series. Yes, they are in series, right? And then I will look at A and B. So I will look at A and B. Are they in series? Okay, no, there is a junction over here and I will put no. So I want you to keep doing all this and then answer down here, is it in parallel for C and D, A and B, A and F, so on and so forth. Okay, and I want you to complete this and this in 5 minutes. So I will switch to my timer now and you have 5, okay, I will give you 10 minutes. Okay, I will give you 5 minutes. 5 minutes enough lah. Yeah, 5 minutes. I'll give you 5 minutes to try. So really 5 minutes. Okay, you have 4 more seconds. Okay, so it is 5 minutes now. I hope you have completed this. Um, so as usual, I will need to break this video down so that uh, I have less chance of making any mistakes. So I will be going through this part of the worksheet in the next video on the playlist, and then after that we will continue with how to combine resistor in series and parallel connection, and then we will end with this exercise of combining resistor to form a simpler circuit. Okay, so see you in the next video.